Alrighty, my name is Amber Splits. This is part 1 of my video for the final week. So we'll just get right into it. As I said, I'm Amber Split. This is my final video for Oceanography. I'm going to be talking about specifically coral reefs and kind of the food chains, interactions between organisms, and how that ties back into oceanography and physical oceanography and all of that. So I guess I don't know where to start. First of all this work is cited from nationalgeographic.com or .org. That's where I got a lot of my information. So I guess, yeah, so these are what I chose for my examples of primary consumers all the way to decomposers when talking about the food chain and the energy exchange. So food web consists of all the food chains in a single ecosystem. Uh, each living each living thing in an ecosystem is part of multiple chains, which is what makes a food web. A food chain or a food web shows the transfer of energy from one organism to another. Different groupings of animals in all food webs represent a different trophic level. There's 3 of them. The first one being a producer, which or an autotroph. They produce their own energy from photosynthesis or chemical synthesizing processes, which we'll talk a little bit more about later. The next one is an herbivore, which eats those autotrophs like plants, and then the next one is a consumer or a carnivore. Also, omnivores fall into that, but anyways, trophic levels. Only a fraction of the energy available at one trophic level is passed on to the next, and then energy is transferred through consumption of other organisms. Coral reefs are the most diverse ecosystems in the world. They are homes as well as areas for spawning, feeding, nursing, and refuge for marine organisms. Yeah, so for my primary producer, I chose cytoplankton, which is in this image right here to the far left top corner. So this is an organism that can produce their own food and energy through photosynthesis or chemiosynthesis. They're also defined as autotrophs, meaning they synthesize, as I said earlier, their own food and energy using sunlight and I guess chemical processes. They're plankton and they're plants. So plankton just means that they rely on the waves and tides to move around. They also so they cannot move freely against the waves or currents. They just kind of float around, or and they're impacted by that. I guess just the conditions of the oceans. They may live in the photic or aphotic zones. They're algae and plants, as I said, so they don't really have things in place that would allow for them to move. Secondly, this one right here, these little shrimp-looking things, these are zooplankton. They're essentially microscopic. They can move on their own to an extent, very minimally, but they are still reliant on waves and currents as well. They also, as do cytoplankton, live in the photic or aphotic zones. They are considered marine animals, where cytoplankton are just algae, essentially. So the zooplankton are primary consumers, which is an organism that makes up the second trophic level. They're herbivores, geez. They're heterotrophs, so they must eat and consume something to get energy. So, as I said before, they're kind of necked in. Uh, they have their adaptations is that they have vertebrae and little legs and things that allow them to actually have movement. That's their adaptation, and their vertebrae kind of give them a shape that allows them to float around better and have more control over their bodies. Um, this picture, the flow is also going from left to right. I just didn't add those arrows in, and then the queen conch is at the bottom. But anyways, this is a picture of a grouper. This is the intermediate consumer. It's an organism that preys on herbivores and other first order consumers. It's a heterotroph. These organisms still get preyed on by top predators like the shark. Um, so this is a Nekton creature as well. It can freely move against the current, against the waves, go wherever it pleases, depending, not reliant on the conditions. And then they typically reside in the pelagic zones. Same thing with the what shark is this? The black tip reef shark. Uh, Same thing, swims in the pelagic zones, Nelkton, but it's the top predator. That's the species at the top of the food chain with no predators of its own. It is carnivorous. Uh, yeah, top of food chain. And then the picture down here, I drew all these arrows going to it because it's a decomposer or a detrivore. That's the queen conch. Uh, it breaks down dead organic materials. It's benthic and benthos. It kinda moves around at the bottom, can't swim freely, so it doesn't really matter about ocean conditions, and then it lives on the seafloor in the benthos zone. Um, Let me get my bearings straight real quick. Um, so I think that's it for the chain, and then we'll go on to the abiotic, impacts and all those good things. So, some of the abiotic factors that affect the reef conditions, or its health and development are, sunlight, and I'll go into these later. Sunlight, water clarity, wave action, oxygen levels, salinity or chemical condition of or composition of the water, nutrient levels, depth, tide, sediment, substrate, temperature, and aerial exposure. So I guess we'll start off with depth and sunlight, which kind of plays back to water clarity. So uh, the depth and the sunlight depth, therefore, impacts sunlight is kind of where I'm going with that. But it changes the structure of the coral and what fish communities are there. So uh, with less sunlight, I mean the phytoplankton and algae and all that, and the coral itself can't synthesize or photosynthesize, I should say, as well with less sunlight, lack of sunlight. And that will change kind of the impact of it. I mean, this picture, I didn't even intend to do this, but this is a good example because you can see where it's growing upwards because it's just like a plant, they grow up to the sun. And then down here, it's not as lively, I guess you could say. Um, and then water clarity, what I kind of mean with that is that it's also like sediment or substrate because with waters, this kind of goes into anthropogenic as well, but like with a lot of wave movement or just rough sediments, not very clear water that can basically smother the coral, um, is suffocated essentially. I mean, they're just like plants. They can't get buried by sediment. They're breathing coral, blah blah blah. Um, Waves, we'll talk about that. So, wave stress has actually been higher. I was doing some research lately because of climate change and higher water levels, but